here we see the 2 by 2 matrix that we have created with 4 different quadrants. So let's start with the first quadrant where we are applying the supervised machine learning algorithms on structured data. This is the simplest quadrant because the data is structured, which is very simple and easy to understand. On top of it, we are applying the supervised learning algorithm. What is supervised? Again, in supervised, we have the target value. So it is simple, right? So the classical examples in supervised structured data are wherever there is a prediction of value which is labeled. It can be predicting time that it takes you to reach your office, or it can be the predicting your business sales. It can even be what is the risk appetite of your customer. It is a low, medium or high, because there are 3 predefined values. It can be that too. Or it can be your stock price prediction. These are the different classic examples. Again, what do we have here? The data is in the form of CSV, or it can be in the form of database data that you collect from data. So the database, which is all structured, where the target value is also defined and properly placed. Now, when you apply this supervised algorithm, there are plenty of supervised algorithms, at least there are a couple of supervised algorithms which can be applied on these structured data to resolve a business problem. These supervised algorithms can further be classified into, can further be divided into regression, and classification. The regression algorithms, the target value, the data that is you're going to predict is a continuous variable. When I say continuous variable, it is a numeric value. The value can change as it goes by. It can be a decimal value, it can be incremented. It can be any value in the form of a number. Whereas in the form of classification, the output or the target value is a predefined value. Let's take the example of the regression. These examples of where you are predicting time it takes you to reach your office comes under regression, because the time can be 9.9 minutes 2 seconds, or it can be 10 minutes 13 seconds also. It is a variable that keeps on changing as per the time, right? It can be predicting sales, it can be $2 million turnover, or it can even be $0.5 million turnover. So the value changes as per the sales. It's a number. And it can be stock price prediction. Stock price again is a number, numeric value. So even that comes under regression. Coming to the classification. What is classification? We define classification as a target value which is predefined. That is, the values are predefined. The values can be only one of these values that are predefined. One of the classic example of the classification is the risk, predicting the risk profile of your customers. It can be in insurance, or it can be in an e-commerce site also. Where your customers are there, if you can understand the risk appetite or a risk profile or buying patterns, you can categorize, you can actually classify, not categorize, the customers into different ways. In this example, we are classifying the customer into high, medium and low. So there are only 3 types of customers in this example, where this risk appetite is either high, medium or low. And if we can predict using our algorithm which type of customer it would be, it turns out to be a classification. One of the problems or challenges we as data scientists sometimes could face is our customer wants us to apply a classification algorithm when he knows some details of the machine learning algorithms. But we realize that the data is a numeric value, that is a continuous variable. And what did we understand? What did we think? We thought that, what did we discuss? We discussed that we have to have a categorical variable that is a predefined value for a classification. But the target value in our domain is actually numeric value. But when our customer says that he wants us to apply a classification algorithm, how do we do that? That could be one of the challenges. Or it can be the other way around too. The target variable that we have is a categorical variable. Categorical variable is a variable which has predefined values. But if our customer wants us to apply a regression algorithm on top, how do we do that? These are the simple challenges, but yeah, it is a challenge because we have to convince our customer. So what we can do is, we convert these target variables sometimes from numeric, that is a continuous variable, into classification or a categorical variable. Or we can even convert a categorical variable into a continuous variable. That way, we can apply a regression algorithm even when our output is a categorical variable. By converting the categorical output target variable into a regression. So the categorical variable, which is the risk index of the customer, will be replaced by something called a risk index, which will have a value from 1 to 10. So based on this data, we will replace this categorical variable high, medium and low to one of the values from 1 to 10 and then use a regression algorithm on top. Now let's take an example where you convert a regression where the output is a continuous output and then you are trying to apply a classification algorithm on top. And how do you do that? Your target variable is in the form of a continuous variable, which you will round it off or maybe take a range of values and specify it as one particular value. Let's take the example of age. Age of the students. Age of the students in the class 10th or maybe all the age of the students who are attending a college function. School function can be from 7 years to 12 years, which is a numeric variable. But when we have to apply classification algorithm on top of it, we have to convert it into categorical variable. In such case, we can probably say 7 to 9 years is one age group, and 10 to 11 is another age group, 12 is another age group, where they are small, medium, and high, maybe something like that. So you have three different values for each group also, where you have converted a numeric value into a categorical value variable with three different values. So this way, you can use a regression algorithm even when the output is a categorical output. You can even use a classification algorithm when the target variable is a continuous variable by converting the target variables into categorical or maybe a continuous variable. This is one simple example. Can be many others.